Hello everyone. I am Mahendra Sharma, Associate Professor and Head of Department of Information Technology. Hope you all fit and fine. Dear students, as we all know that due to Corona pandemic, the whole country has locked down itself. But our college, IIMT College of Engineering, Greater Noida, aggressively taken the decision to not letting down your academic in any way and start the online classes in the form of lecture series. So in this semester, I am going to dealing with the subject design and analysis of algorithm for the fifth semester student of CS and IT. Design and analysis of algorithm is one of the core subject of BTech program. There are some prerequisites to learn these courses, like the good knowledge of the data structure and C programming and basic knowledge of the mathematics. So let's start. So my first slide is the acknowledgement. Before proceeding further, I would like to acknowledge the lecture notes has been summarized from lecture notes on data structure and algorithm, design and analysis of computer algorithm all over the world. I can't remember where those slides come from. However, I would like to thank all professors who create such a good work on those lecture notes. Without those lectures, this slide can't be finished. Now, question is that what is the objective of the course? Means students will be able to do the following. After the completion of this course, student will be able to analyze the performance of algorithm, demonstrate the major algorithm and data structures, apply important arithmetic design, methods of analysis, and efficient algorithm in common engineering design situations. Design and analysis of algorithm. This is the two parts, analysis and design. Analysis, predict the cost of an algorithm in terms of resources and performance. Resources may be time and the required space. So we are in the need to analyze time complexity and the space complexity. Design is nothing but it's a procedure to design the algorithm which minimize the cost. Now introduction to asymptotic analysis. Now question is that why asymptotic analysis is required? As we know, there may be more than one approaches to solve any particular problem. Suppose suppose you have given a problem P1 and there may be more than one approaches to solve this problem. Suppose A1, A2, A3. Means in the computer science, for this particular problem, there may be more than one approaches to solve the problem. But which one is the better one? In the terms of time complexity and space complexities, that is the important. To know which one is the better one, analysis part becomes the very important. So knowing the complexity of algorithm allows you to answer questions such as how long will a program run on an input, how much space will it take, is the problem solvable. So these are the basic questions comes in the mind. To answer such kind of the questions, analysis parts becomes the very important. So these are important basis of the comparison between different algorithms. And an understanding of the algorithm complexity provides programmer with insight into the efficiency of their code. Complexity is also important to several theoretical area in computer science, including algorithm, data structure, and complexity theorem. Now, asymptotic notations. Basically, this is the topic belongs to mathematics, and as the lot of functions are involved in the asymptotic notations, so because of that, it's becomes very important to understand the things, because asymptotic notations are mathematical tools to present time algorithm for asymptotic analysis. So there are three kind of the asymptotic notations, so which are mostly used to represent big O notation. Big O notation basically used for the upper bound. Second one is the theta notation. Generally, it's used to show the lower and upper bound. Yeah, you can say the average bound, and big omega for the lower bound. So let's discuss one by one. Big O notation. Okay. So big O notation define an upper bound of an algorithm. Its bounds definition says order of g of n equal to f of n if if there exists positive constant c and n0 such that fn is greater than or equal to 0 and less than or equal to c of g of n for all n greater than or equal to n0. What the meaning of this definition? Let's discuss with the help of this problem. See, I have written some functions comparison over here. One is less than log n, less than root n, less than n log n, less than n square, less than n cube, and so on. So actually what big O says, order of g of n equal to f of n if and only if there exists positive constant c and 1 and 0 such that fn is greater than or equal to 0 and less than or equal to c of g of n for all n greater than or equal to n0. Actually what it means? It means suppose you have given a function 2n plus 3. So for this given function, what will be the value of g? Find the value of gn, the right side of this function. So we can write something which is greater than fn. So just I have written 10n. So just check out whether this equality is true or false, right? So for n is equal to 1, let's check. For n is equal to 1, 2 multiplied by 1 plus 3, 5, 10 multiplied by 1. Okay. For n is equal to 1, this equality is okay. For 7n, it becomes also correct. For 1000n, it becomes also correct. And for the any value which is greater than or equal to 1 will be correct for this equation. Now, there is a question. How much we have to struggle to find the values, which one will be the correct for this equation? So rather than guessing whether 7n will be great, satisfy the equation, or 10n will be satisfy the equation, 1000n will satisfy the equation, it's better write the equation in this form. We have given the function 2n plus 3 at the right side, just like 2n plus 3n. Just check out. For n is equal to 1, for n is equal to 1, 2 multiplied by 1 plus 3 becomes 5, and 2n multiplied by 1 plus 3 multiplied by 1, this becomes also 5. It means you can say for n is equal to n greater than is equal to 1 and c is equal to 5. For the c is equal to 5 and n greater than is equal to 1, this equation will be true. So you can say this is your c and this is the g of n, right? So now you can write this equation like that: f of n is equal to order of g of n is equal to order of n. Means now you can write this like f of n is equal to order of n. Okay. Now question is that there is only one solution, whether f of n is equal to order of n square will be correct or not. Yes, correct. How? To understand how come to this point and see. Actually, we are talking about the upper bound of the function. So greater than n, all the function will satisfy the condition. So now question is that whether f of n is equal to could be order of log n. No. Why? Because log n lies left side of the n and which is the lower bound. So this is the incorrect. But yes, f of n is equal to order of n square could be, right? Similarly, another notation is the another example for the same problem. See, suppose you have given the equation 3n plus 2 and g of n, then prove f of n is equal to order of gn. Okay, as we know by the definition, f of n is less than or equal to c of g of n when c is greater than 0 and n0 is greater than or equal to 1. Let's put this value. 3n plus 2 is less than or equal to c of n. Here put n is greater than 3. So this equation become the 3n plus 2 is less than or equal to c multiplied by 3. Let's see. And whether 3 of n plus 2 is less than or equal to 4n. 3n plus 2 is less than or equal to 4n. 4n is equal to n. For n is equal to 1. Yes, because 3 multiplied by 1 plus 2 is less than or equal to 4 multiplied by 1. So whether 5 is less than or equal to 4. No. Let's put n is equal to 2. So check whether 3n plus 2 is less than or equal to 4 multiplied by 2. So 3 multiplied by 2 plus 2 is less than 4 multiplied by 2. Whether 8 is less than or equal to 2. Yes. 8. Yes. So what we can say for the c is equal to 4 and n is equal to greater than or equal to, this equation will satisfy. Okay, so n is greater than or equal to 2 and c is equal to 4. Now question is that whether f of n could be order of log n. No. Okay. So let's move for the another notation. Big omega notation. This notation basically used for the lower bound. So big omega notation provides an asymptotic lower bound. Be useful when we have lower bound on time complexity of an algorithm, function g of n, right? So what's the definition? Omega of g of n is equal to f of n if and only if there exist positive constant c and n0 such that c of c of g of n is greater than or equal to 0 and less than or equal to f of n for all n is greater than or equal to n0. Okay, so what it means, let's try to understand with the help of the example. Again, we are going to take the same example. Suppose we are given the value of 2n plus 3. F of n is equal to 2n plus 3. Whether this is greater than equal to what? So we have to find out the value for the right side that satisfies this equation. So 2 of n plus 3 whether greater than equal to 1n. Yes, for n is equal to 1. So let's check. 2 multiplied by 1 plus 3 is greater than or equal to 1. Yes. So we can say for c is equal to 1, n is equal to 1, we also can say is equal to 1. This equation will be satisfied. So what it means? Let's try to understand from the above equation. The values, those are lies left side of the n. So any function can be the answer of these equations. Correct? Okay. Similarly, with the help of another example, f of n is equal to 3 of n plus 2, g of n is equal to n, then prove f of n equal to big omega of g of n. So by definition, as we see in the previous slide, f of n is greater than is equal to c multiplied by of gn, whether c is greater than 0 and n0 is greater than or equal to 1. So let's check. 3n plus 2 is greater than or equal to c multiplied by n, whether c is equal to 1 and n is greater than or equal to 1. So let's check with the help of calculation. let's check this value. 3n plus 2 is greater than equal to c multiplied by n. C, value of c is given 1, the value of 1 is given 1, so 3 multiplied by 1 plus 2, so this becomes 5 is greater than equal to 2. Yes, correct. So we can say for n is greater than equal to 1 and c is equal to 1, this equation fn is equal to 3n plus 2 comma g of n is equal to n will be f of n is equal to big omega of g of n. Okay, now next notation is theta notation, one of the very important notation used to represent the average case of the algorithm, average case time complexity of the algorithm. The theta notation bounds a function from above and below. So its definition as asymptotic behavior f of n equal to theta of g of n if there exist positive constants c1, c2 and 1, 0 such that c1 g of n is greater than or equal to 0 and less than or equal to f of n, and f of n is less than or equal to c2 g of n for all n is greater than or equal to 1, 0. So the above definition means if f of n is theta of g of n, then the value f of n is always between c1 g of n and c2 g of n for large value of n, and must be greater than or equal to n0. The definition of theta also requires that f of n must be non-negative for values of n greater than 1, 0. Let's understand the concept with the help of example. Okay, so again I have taken the same example. As in the previous slide we have seen, for the lower bound, for the equation of 2n plus 3, lower bound was c of 1 and n was greater than or equal to 1. So this, so let's check 2 multiplied by 1 plus 3, 5. So 1n, 1 multiplied by 1 is less than or equal to 5 is less than or equal to 5 multiplied by 1. So 1 is less than or equal to 5 and less than or equal to 5. So we can say yes, the lower bound of this equation is 1 of n and upper bound of this equation is 5n. So we can say 1 is the c1, 5 is the c2. This is the g of n and this is the g of n. Okay, right. So we can say yes, for c is equal to 1, c2 is equal to 5 and n is greater than or equal to n0, fn is equal to theta of n. So let's move for the next slide. Now space complexity calculation. What is the space complexity? It's basically required space to store the instructions. How we are going to calculate the space complexity? Basically there are two factors. The space of an algorithm is determined by two factors, constant and dynamics. So S of P is equal to, well, space complexity is equal to C of P plus D of P. Example, suppose you have given a code of 2 lines. Int Z is equal to A plus B plus C, return Z. So how many variables are involved in this line? 1, 2, 3, 4. And what kind? Integer kind. Integer type. So integer data type, as we know, integers required 4, and now size of the integer. So 4 multiplied by size of integer. So space is equal to CP. Why 16? Because there are the 4 variables. So 4 multiplied by 4. 4 is the size, 4 is the variable. So one variable required 4. So 4 variable will require 16 bytes. So this line will require the space of the 16 plus return Z. How many variables are there? 0. And what is the size? 4. So 4 plus 0. So total becomes the 16 plus 4 multiplied by 0. Total 16 bytes. Right? Let's move forward another slide. So students, this was about the introduction of the algorithm and asymptotic notation. So let's summarize. I have discussed about the asymptotic notation, and I said there are the 3 kinds of the asymptotic notations we are going to use in the algorithm to represent the time complexity of the algorithm. First one was the big O for the upper bound, big omega for the lower bound, and theta for the average case analysis. So thank you very much. Take care. We'll meet in the another lecture with the next topic. Thank you very much.